All right, students, I think that most of you have come. So we'll start again. So we were discussing about the probabilistic reasoning and the Bayesian networks. So these are basically the machine learning techniques. These are the machine learning and the data-driven approaches that we have already discussed before, the expert systems. All right, so these are basically the continuation of that thing as well. So they actually specialize these probabilistic and Bayesian networks. These handle the uncertainty and make the inference from the data. So where do we use this probabilistic reasoning? It actually involves the probability to handle the uncertainty. Uncertainty is basically that we are not actually sure about what the probability of a particular thing is going to be. So this is uncertainty. Like, for example, we have a problem and we are not having the proper, we are actually unsure about how it's going to end, which way are we going to go. All right, so this is basically uncertainty in the terms of probabilistic reasoning as well. So in real world data scenarios where the data is very rare, we use the probabilistic reasoning in order to get a single outcome, um, which actually is incorporating the uncertainty, the variability of how the data is going to be used, how the data is going to differ. All right, so we actually use the models to weigh the likelihood, the probability of the different outcomes. Likewise, we discussed about the example of rain. We determine on the basis of the previous data that if it's going to rain tomorrow or not. All right, on the basis of the um, we have a target class whether or not it's going to rain. So what do? We use the Bayesian theorem. Bayesian theorem is basically a machine learning algorithm which is basically used for this particular machine learning. It's a machine learning technique. All right, it's basically used for the medical diagnosis in the healthcare, risk assessment, patient care optimization. Actually, this Bayesian networks, these use the directed graphs. All right. Actually, I had something to show, but okay. So what actually directed graphs are that one problem or one situation is pointing to another situation. All right. It's basically that a variable is actually responsible for another instance, then it's responsible for another instance, and that is going back to that first instance. So this is basically directed acyclic graph, or we say that it's basically a directed graph. So these Bayesian theorems and the probabilistic reasoning, these basically use these theorems. So we actually use the probabilities and different techniques to solve this. So people, I have an assignment for you people, a short, very short homework that you have to search on probabilistic reasoning and Bayesian networks. You people have to search about it in the domain of healthcare. All right, you have to find an example that is related to the medical diagnosis or risk assessment or patient care optimization. Okay, so you people have to do this brief assignment. It's basically homework for your practice because it's going to involve some probabilities, and we'll go through it in the next class. And you people will share your work that you have done. I hope that everybody has got this.
Yes,
Okay,
ma'am.
I'll repeat for Dr. Saeed as well. He has joined right now. I was saying that about probabilistic reasoning. All right, you have to just search about probabilistic reasoning, but about Bayesian networks, you have to search about it, and you have to find an example that is related to your medical diagnosis or risk assessment or patient care optimization, some sort of it's related to healthcare. All right, and you have to solve that example. It can be numerical as well, or it can be a general problem. All right, so we'll discuss this in the next class. I hope that everyone has got this.
Yes, ma'am.
All right. So, um, in continuation with the machine learning and the data-driven approaches, we have picture archiving and communication system. So it's basically not AI based. Picture archiving and communication system emerged in the 1990s. It was basically a storage system, a digital storage system, and the distribution system for the medical imaging. All right, it was basically an advanced tool that was provided for the essential data for the medical imaging tools. So how did this work? It was basically working on the basis of, like, we have a sort of a database, a digital store, and it's going to work um, in the form of, like, it's going to store that data. It's going to store the medical data. It's going to store the images. The medical imaging, what actually the medical images are, the x-rays, the different, yes, mostly they're x-rays, they're different images. There are the images of, for instance, of the of any eye disease or any disease. All right, so we have a large amount of data of the medical imaging data. All right, so these were basically used for this archiving system. Archiving is basically that even if that data is large, that is going to remain stored in that. All right, it would be archived, but it is going to remain in that. All right, and it was also a communication system. Okay, we could communicate that data. It was basically a digital storage space for this the data. All right, how the communication was done? It's basically, it actually allowed the, am I audible?
Yes, ma'am.
Yes. Okay. Okay.
Yes, ma'am. Now you are
So,
audible. Before you were not.
okay. All right. Actually, now we have a problem. Actually, I recorded the session, the last 40-minute session. I actually started it and it is not having any volume. So that is why I was just shocked that why it did not record the whole class. It's only showing a black screen in the recorded session. So I don't know what's the problem with it. Actually, I started the screen sharing and recording, but it did not record anything. All right. So how did this PACS system communicated? It actually allowed the images to be shared securely among the healthcare facilities. All right, like we have now EHRs, electronic health records. At that time, in the 1990s, we had the digital storage systems. All right, so it was very easier for the specialists, for the different healthcare faculties to view and collaborate on the patient's case. All right, at that time, this was how the medical data was being studied and being worked on. Then it had a plus point that it was accessible to many clinicians. They could access it, they could analyze the images anytime from anywhere because of the different networks. At that time, the networks were basically different. It did not have they did not have internet at that time, but still the networks at that time, they were basically this much capable that the uh, clinicians could access those images or that data from the remote areas as well. Then the integration between the healthcare systems, all right, between the EHRs, radiology information systems, between different systems, it actually made the this whole thing comprehensive, and the patient data management, it became a very easy task at that time. So now, if we talk about the computer-aided detection, computer-aided detection is basically it was invented during the late 1990s. So it was AI-based computer-aided detection systems which started assisting the radiologists by flagging suspicious areas in the medical images, such as mammograms. All right, so basically, computer-aided it's basically computer-aided detection that was basically like in the we can say in the AI-based systems, computer-aided detection systems, it was um, actually it started assisting the radiologist. Now, how did the radiologist get benefit from this? That okay, can you please excuse me for a minute? All right, I'm really sorry for the disruption. So we were actually discussing about the computer-aided detection systems. They were the advanced medical imaging tools for the radiologists and the healthcare providers, which could identify the different abnormalities like tumors, the medical images, um, the images that had fractures, lesions, X-rays, MRIs, and CT scans and whatnot. So these systems actually used at that time, because we have studied that the machine learning was basically used at that time. All right. And artificial neural networks were also used in the 90s, if we have discussed. So basically, the machine learning algorithms, pattern recognition, the image processing techniques. Pattern recognition is basically that, for instance, if a particular image is given, the images, we have to find that how do they differ. So this data is basically trained to the algorithm, to the model, and then on the basis of this, we give some sort of other image out of that is out of the box, and then we see that if that data is going to predict that right or not. All right, and we have made a model that how on what basis it's going to predict this classification of this, and if it's going to predict the other one. So this is how the machine learning algorithms, the pattern recognition, the image processing techniques are used in the suspicious areas in the images, which help the radiologists to make the diagnosis faster, all right, and potentially more accurate. Now, how did uh, computer-aided detection systems help? They basically scan the images for specific patterns, all right, So CAD, okay. So CAD basically scanned the images for the specific patterns associated with the medical conditions, like nodules in the lung CT scans, like in the in the mammograms. All right. So basically, these were the flag areas. All right, the red areas where we could view it further. All right, how is it affecting the patient badly? Then it uses the algorithms that are basically driven on the analysis. All right, these systems actually use the algorithms trained on the vast data sets of the medical images to detect the subtle and early stage abnormalities which cannot be found or which cannot be detected with the naked eye. Okay, the doctor, it becomes really difficult for even the clinicians or for even the healthcare professionals to detect those images at those stages. So this is where these algorithms or these systems helped. Then it also reduced the human eye error. All right. How did it reduce the human error? By acting as a second set of eyes for the humans. These systems actually reduce the human error and due to the fatigue or oversight, especially in the high volume screening scenarios. So this is how it actually reduced the human error. Then these CADs were actually integrated with the picture archiving communication systems that we have discussed before, PACS. These were actually integrated. When both of these were integrated, they allowed for seamless access. Like we had a digital database as well for the storage of the data, and also we could easily detect or analyze or reduce the human eye error by using the CADs. All right, and the images could actually be managed within the existing hospital workflows. So where these CAD systems were used in the mammograms, we have seen this example. So mammography was basically used. It actually highlighted the potential breast cancer lesions, helping the radiologist to focus on the areas of interest, like how it could help. Then in the lung cancer screening as well. Now, CADs could assist in detecting the lung nodules in the CT scans. All right, how did it affect the um, lungs? All right, from the images, those could be detected very easily. All right, which could not be actually detected by the human eye easily. So it improved the early detection of rate of the lung cancer as well. Then it actually implied using in the colonoscopy as well. All right, in the virtual colonoscopy, these systems were used and these could identify the polyps in the CT colonography images. Um, then we can take another example of this as in the brain imaging. How did it actually help in the brain imaging? Was that CADs could help detect the stroke indicators or the brain tumors by highlighting the suspicious regions in the MRI or CT brain scans. All right, so this is how it's going to affect it's going to be, it was basically used in the different applications like we have discussed in the mammography, in the lung cancer screening, in the brain imaging, in the colonoscopy. All right. Um, all right. Can anybody of you students please um, just explain what do we refer by colonoscopy? Actually, how did it help? How did these systems help in this colonoscopy? Any one of you, please. So we have Dr. Talha Yaqub.
Yeah, ma'am, I'm here.
Okay, please explain what is colonoscopy and how would we actually use this CAD system in that. I have explained this right now.
Ma'am, it's like in colonoscopy, we can get some images, and later on, like if uh, there would be some kind of cancers, the computer-aided detection system can early help us to analyze, which
Yes,
the doctor cannot see by a naked eye while
yes,
examining.
yes. So it could actually identify the polyps in the CT colonography images. All right. Then we discussed about the brain imaging, lung cancer screening, and then mammography. Now, how are these CADs beneficial? These actually enhance the diagnostic accuracy, help the radiologist by identifying the abnormalities that otherwise were missed by the doctors by in their human eye, all right, at the early stages. Then the CADs also increase the efficiency, all right. It assisted in large screening of the large amounts of data and to reduce the time per case and allowing the radiologist to see more patients. Then it also improved the patient outcomes, how actually earlier and more accurate detection. It actually led to more timely interventions. All right. So basically, along with some benefits come the limitations as well. Now, what actually the limitations were? They were more false positives. It means that the CAD systems could sometimes detect the benign findings, which were suspicious, which led to unnecessary follow ups or biopsies. Then it also depended on the quality of data, all right? How the data is actually, how the data is used. For instance, if the images, they were blurred, there were some errors on there were some, the images, they were not having proper pixels, all right? So it was basically like the data quality error, all right? It depended on the data quality. Then, as we have discussed, that the CADs were integrated with the PSES, with the picture archiving and the communication systems. So it also required large amounts of costs. So implementing the CAD systems with the hospital networks, it required the integration with existing IT infrastructure, which actually was very costly and complex. So this is how we actually moved further from the computer-aided detection systems to the rise of deep learning and big data. So what deep learning is? Deep learning is basically that we have actually invented, we talked about the ANNs, that the artificial neural networks are basically based on the neurons, the neural system of the human brain. All right. So how is it related to deep learning? Deep learning is basically that on the basis of those hidden features in the artificial neural network, on the convolutional neural networks, these this field emerged, and the hidden features, they could not be studied. All right, the feature extraction could be done automatically. The feature selection could also be done automatically. For instance, I took an example of a very large data set. For instance, we are having 50 features, and those features cannot be taken into account because we don't know that which features are having a high weightage for some for this problem. All right, so what would we do? We will use machine learning, either machine learning algorithms, all right, it could be classification, it could be clustering, it could be some other problems, algorithms. So, and that's how we would just go on and use some um, feature selection algorithm in order to get the selection after using the correlation. After getting the correlation, how is some feature related to another feature? How much weightage do both of the features have on each other? So that was basically done manually by the use of algorithms. In deep learning, we actually used directly the models directly, which could just use those features, the input features, all right, and it actually did not have to go through all of the hidden layers, directly gave us the outputs. So this is how the deep learning evolved, and big data also evolved. So deep learning is a subfield of machine learning involving multi-layered neural networks, and became the catalyst for AI's resurgence. The availability of vast datasets, known as big data, coupled with the advancements in computing power, enabled deep learning models to outperform the previous methods in the image analysis and natural language processing. So basically, this is how it evolved. Big data evolved, then deep learning also evolved from the machine learning. We mainly the deep learning based algorithms are convolutional neural network and artificial neural networks. Along with that, there are different hidden Markov models. Um, they're natural language processing, image recognition. For image recognition, we use different BGZ16, YOLO V8, YOLO V5, and very different aspects of the data sets are there. And along with these models, we have um, different parts of those models, which are like activation functions, training with the backpropagation, optimization algorithms. So these are actually the part of this. So people, are you studying any course in which you will go through the programming or in Python or in machine learning algorithms or deep learning algorithms? I want to know because that is basically the basis of this course as well.
We are not sure.
Which courses are you studying at this time? Like, in this semester, which courses are you people studying?
Madam, I don't remember all the names. These are mentioned in a Word document in the group.
All
Ma'am, we're
right.
studying AI principles and techniques, electronic health records, medical imaging technologies in AI healthcare, big data challenges and evolutions of AI application in healthcare.
Yes, big data तो आप लोग मेरे साथ पढ़ रहे हैं. बाकी जो courses हैं, they're AI techniques. All right. So in AI techniques, I hope so that you will the people will cover that these algorithms over there as well. So you would get a better know-how of this, of the deep learning and machine learning models. But I will definitely uh, we'll have to have another class for this whole workshop sort of thing, in which we have to go through all of these things in detail. Otherwise, until we have not gone through those points, you people will not get a deeper idea of what things are going on. So basically, deep learning was the subfield of machine learning, um, using the multi-layered neural networks. Then the availability of vast data sets known as big data, coupled with advancements in the computing power, enabling the deep learning models to outperform the previous methods in image analysis and natural language processing. Okay, so key breakthroughs for the uh, rise of deep learning and big data. We have the deep learning in medical imaging. So how did deep learning benefit the machine learning? It actually began to significantly impact radiology by improving the accuracy of image based diagnosis. For example, the convolutional neural networks, they demonstrated remarkable capabilities in detecting the cancers, brain tumors, eye diseases like diabetic retinopathy. I actually shared a workbook uh, of this diabetic retinopathy detection that day on my screen. I would make sure that we go through it again, once again, in the next class. It would be a sort of a short session in which I would go through the programming functions as well as some overview of the models of machine learning and deep learning. So I would share that a document, I would create a document and I would share that beforehand before our next class when we have the next class in the next week. All right. So IBM, 2011, IBM Watson 2011, developed by IBM, gained popularity after defeating the human contestants on the game show Jeopardy. This success sparked interest in the potential applications in human care. Watson Health began exploring applications like drug discovery and personalized medicines. So, AI is also used in the drug discovery as well. How that in order to create some different or new to invent new medications, all right, we use different algorithms or we use different AI uh, instances to create or to work in the drug discovery as well. And to create the personalized medicines, we use different tracking devices, we use different applications in order to for the patients in order to have their own personalized medicines to keep a track of them. All right, so this is how these applications were used in the drug discovery as well. So key achievements, again, we're having the key achievements of deep learning and um medical imaging, deep learning in the medical imaging, AI for cancer detection, early cancer detection. Cancer can be detected later on as well, but for early detection, these systems, these models were used, algorithms were used. These were trained on different data sets, all right, vast amounts of data sets of the images they were used, and in order to detect the early signs of cancers like melanoma or breast cancer with higher accuracy. That day we had discussed an example of melanoma as well. That, for example, if we have a case that we discussed about the biasness of the data, that if we have a data set and the white people, there are more white people as compared to the black people, and it basically is like the lesions is detected by the lesions on the face, all right. So if there are less black people and there are more white people, so the data is biased, all right. It's definitely going to detect it's going to detect that the patients are having the this melanoma, all right. So this is basically about the programming side. Now, natural language processing. Natural language processing models started being used in the electronic health records management and understanding the clinical notes to provide decision support. Natural language processing is basically on the basis of the different, not on the basis of the structured data, but it is basically unstructured data. All right. It's basically a continuation of the deep learning that these models they were basically used. So it basically focuses on the computers to understand the human language. All right. Like for instance, you people might have used some of the AI some of the AI platforms uh, to work. For example, mostly people use like Gemini. So what do we actually do there? We are actually talking to a chatbot. We call it a chatbot, and we talk to it. We question different. We enter different questions, and we are answered about that. We are answered to that. How does it happen? It's basically that that chatbot is trained on a vast amount of data. All right, and it actually uses different models. Like it uses LSTMs, long short term memory models. Then on the WhatsApp, you're having that Meta AI. So what do we do? That is basically, again, once again, we are asking questions and that is generating answers. That is also being made on vast amount of data. It was trained on a large amount of data. All right. So the word enter, the word that is basically generated to us, it's basically a continuation to the last word. All right. It basically detects the probabilities of which word to generate and what to not. So this is how it's actually going to continue. So NLP models started being used in the electronic health records management. Basically, and understanding the clinical notes to provide the decision support. In electronic health records, so we're having once again less than 1 minute. All right, so we'll start our class at 9:12 because the class is going to end again. Um, so we'll start our class after 10 minutes from here.